This is a demonstration of the second generation Toyota Prius hybrid system operation as far as the electrical high voltage components in that system. We have here at Weber State University a partnership with Toyota for our associate degree Toyota T10 program, and also for our bachelor's degrees in field service operations and advanced vehicle systems. And so we teach hybrid system operation and hybrid safety to our students. We'll start with the high voltage battery that is in the back of the Prius. This is a 201.6 volt DC nickel metal hydride battery. This is an alkaline based battery. The battery itself is fairly heavy, and it's located behind the back seat in between the wheel wells. This battery has the computer that controls it, and then of course DC cabling that leaves the battery. But while we're here on the high voltage battery, notice also that we have an auxiliary battery, the 12 volt battery. So on all hybrid vehicles that I'm aware of, we still have a 12 volt battery that needs to be charged and runs the rest of the vehicle, but the high voltage battery is different and only is for the high voltage electric motors in the transaxle. But if we look closely down inside the battery here, we have positive contactors, negative contactors, and a precharge contactor. Think of these contactors as high voltage relays. And so the orange cables coming in on the left here are from the DC high voltage battery itself. And then once the relay contacts close, we connect the two terminals together with the relay contacts, and then apply the DC voltage to these orange cables that goes up to the front of the car to the inverter converter assembly under the hood. The precharged capacitor is there across the negative contactor, where when we close the negative contactor, right before we close it, we turn on this precharged contactor, which, as you can see, has a high wattage resistor. There's a capacitor involved where it equalizes the voltage through a capacitor across the contactors, and then closes the contactors themselves to minimize arcing and prolong the life of the contactors. And all hybrid batteries that I'm aware of have at least a precharged contactor and one either positive or negative contactor. This one actually has both. So what that means is that these high voltage wires here don't have any power to them at all if the key is off, and as long as those relays are off, which when the key, it doesn't have a key, when you turn the power button off and you turn the power off to the vehicle, or if you disconnect the 12 volt battery, the 12 volt system is what controls these contactors, and it will open circuit the high voltage. Now on the back of the side of the battery case, we also have a service plug grip that has to be installed in order for the battery circuit to have continuity. And so when we install this, we push it in, rock up on the service plug grip handle, and then we push down. By pushing down, we've got a little 2-wire circuit there, the isolation circuit, that lets the computer that's in charge of the high voltage system know that the service plug is installed. When we disconnect this plug, we're just going to lift up on the plug, rock it out, and pull it straight out. And inside of this plug is a 125 amp fuse that's actually built into the plug itself. You can't buy it separately. The service plug has to be purchased by itself if the fuse for some reason is blown. But we have the high voltage battery with its positive and negative contactors and the positive and negative cables, but this service plug grip that we just pulled out interrupts or open circuits this series set of batteries that we have underneath the case here. And I've got a picture I've printed of the inside of the battery with multiple battery cells at 7.2 volts apiece, all of them in line with each other. But we've got contactors that connect or disconnect the high voltage battery, and once again those are controlled by the 12 volt system. So if we follow this cable right over here, and this comes up through the trunk area, we have a wire that is labeled from the 12 volt battery. So on our 12 volt battery right here we have the negative terminal, which has just a little tiny short battery negative cable that bolts to the inner fender, and then we have a positive cable that comes all the way from the inverter converter assembly. There's a big heavy white wire on the bottom of the converter inverter assembly right there that has a wire that comes all the way back to connect to the battery positive terminal of the auxiliary battery, and then this also connects in there and goes all the way to the front of the vehicle on this black wire. So the two orange wires are positive and negative high voltage DC. That black wire comes all the way to the front of the vehicle, and right on the driver's side underneath the hood is the underhood fuse block, and this is the power feed to the fuse block itself. So let's look again. We've got the high voltage battery, we've got the big heavy orange cables that go underneath the car and go all the way to the front to the power inverter converter assembly that's normally covered with this cover right here. So I'm sure you guys that have been under the hood of a Prius, second generation Prius, recognize this battery cover, or the inverter converter cover, not battery cover. That cover covers up a bunch of electronic components that we're going to talk about here in just a moment. But while we're here, coming off the rearwardmost part of the inverter converter assembly under the hood, we have three-phase cabling that goes out and goes to our motor generator number 2 stator windings. There are 3 sets of windings there. And then I have a separate video on the second generation Prius hybrid electric motor operation, but this is motor generator 2 that drives the ring gear of the transaxle. And so our inverter converter assembly rear connection is what supplies power to the rotor or stator assembly to drive the MG2. This is a Y-wound stator. It also receives current during deceleration for regenerative braking. And then coming off the front bottom of the converter inverter assembly, we have more three-phase cabling right here that goes and drives the MG1 stator assembly. This is also a Y-wound stator. In this mock-up I've disconnected the center connection of the Y wound stator, and I've color-coded it for demonstration purposes with my students. But MG1 is this smaller electric motor here that drives the sun gear of the transaxle assembly. And then our internal combustion engine, of course, drives the planet carrier. But the inverter converter assembly here on our wall is what is in control of driving both MG1 and MG2, and also receiving the current from them during deceleration. Now this thing gets really hot And so we've got another inverter converter assembly that's disassembled, and we're looking at the bottom of it here. You can see the cooling passages, and you can see some coolant connections. We have an electric water pumps, a pump also in this system. It's got its own cooling system. It uses the Toyota long life, super long life coolant, same as what's in the radiator, but two separate container systems. This is the fill tank, the surge coolant tank for the power electronics portion of the radiator. Now, let's get back to the converter-inverter assembly. The very top piece that we're seeing here is a big pack of capacitors. And if we come over here to where I've got it disassembled, a second one disassembled, we can see the capacitor module right here on the wall, and it actually has the capacitor sizes, although it's upside down, listed here, the capacitors involved in this circuitry. We have 1130 microfarads, 282 microfarads, and 0.1 microfarad capacitors there that are part of the overall motor driving circuit that is involved in this second generation Prius. Now right here underneath the capacitor module we have what's called the intelligent power module, the IPM. Well, the intelligent power module has isolated gate bipolar transistors, 6 of them. So these 6 connections here go down and underneath, and there's a huge heat sink that connects to the coolant, or the aluminum, where it's liquid cooled over here. Those transistors are what drive our 3-phase cabling. So the 3-phase cables that connect to the inverter module that drive MG1 connect here, and that's these 3 connections. And then our MG2 connection comes out over here, and that's these 3 wires, big heavy connections. We've got some current sensors. We've got a computer that's in charge of the inversion of DC input. We've got our DC input coming in right here, and then this is our AC output. So we're inverting DC to AC to drive the motors. And then during deceleration, we've got 6 gigantic diodes in here that act as a rectifier bridge. So we've got basically 2 alternators, our MG1 and MG2 motors, that are used during deceleration to apply a voltage and send current back. So we go from AC back to DC, we convert it, and then that goes back to our high voltage battery. Now between the inverter converter assembly, this intelligent power module, we also have what's called a reactor, which is just a big coil of wire. It's an inductor. And then we have another IGBT module that's called the boost converter module, and it's going to step our voltage up or down DC. We have our DC power coming in here. It's stepped up and then fed to the inverter converter assembly. But there's 2 transistors and 2 diodes in this boost converter module, and we use that to fully activate the inductor by pulling it to ground on one side, providing power on the other, build a huge magnetic field, and then when that field collapses, we route that high voltage along with the high voltage from the battery to the inverter converter assembly, and we can step the voltage up. Now on the second generation Prius we can step it up as high as 500 volts, but that stepping up is done through this reactor, as Toyota calls it, in our boost converter module, which is made by Mitsubishi. So in our overall schematic here, we've got our high voltage battery right here. Here's that reactor coil of wire, and we turn on this transistor in the boost inverter power module, and we get a complete loop which energizes this reactor. We build a huge magnetic field. We turn this transistor off, and then we turn this one, or no, we leave that one off also. When the field collapses, the polarity is positive minus, and through that diode we can supply the inverter converter assembly for the two motors. Now also, excuse me, in the converter inverter assembly underneath it is, as you can see here in this diagram, a DC to DC converter and an air conditioning system inverter. And so that is this plate right here, this aluminum housing with the circuits and parts inside of it. In there we have these two wires right here that are 201.6 volt DC input. Those two wires actually reach clear up through a hole right here. Those wires will stick up and connect to these same two wires from the DC 201.6 volt battery. So those wires connect to the high voltage battery. They will come in, over and up, and then we have our air conditioning system inverter. So this is the same type of inverter system that we use to drive MG1 and MG2. It's just in a smaller form. So we have our DC cables coming in, we have our three-phase cabling going out, and if we follow this orange wire, then we come down to our electric air conditioning compressor that, as you can see with the three cables here, it's also a three-phase AC electric motor, and it's a variable speed air conditioning compressor. There's no fan belt. We can speed the compressor up or down depending on the refrigerant needs and cooling needs in the evaporator. So that's our air conditioning system inverter assembly. And then we also, to charge the 12 volt battery system, the auxiliary battery here, which is behind the, what's in the right rear of the car, we have to have a DC to DC converter assembly to take our 201 volts DC in and then run it through this center tap transformer and a series of diodes, another inverter, or another inductor, reactor, and then to the 12 volt system. And with the system powered up, even though we say it's 12 volt, we get around 14 to 14 and a half, even as low as 13 and a half if the 12 volt battery is pretty low, volts for our charging system voltage constant. There is no alternator on this system. This DC to DC converter is what actually drives, or I'm sorry, charges the auxiliary battery on the vehicle. While we're here, I've got some personal protective equipment that I want to show you. We have some high voltage gloves. These are some old expired ones, so I poked a hole through them. But let me take those off and show you the rating and the date on those. If we can zoom in here, there we go. You can see these are made by Salisbury. They are class 0. Get that focused. Focus. There we go. Class 0 gloves, which is what they need to be. Notice these were tested September of 2007. You're not supposed to let these go more than 6 months without either replacing them or having them recertified. So these gloves are no good, and so I've got them just hanging up to show a pair of gloves in my classroom. But if you wear these gloves just on your hand, it's not very long at all before you get really sweaty. And so they also sell what's called an inner glove, which is basically just a gardening glove that you can get like at Home Depot. That inner glove will allow your hand to breathe. We got an airplane going overhead. It'll allow your hand to breathe while it's inside of the high voltage glove, and then we protect the high voltage glove with this leather outer glove, and you should put them on both hands as you're working on these vehicles. Now just let's look at an overall, or let's review just one last time, overall system operation and voltages. We've got our 201.6 volt DC battery that when the engine is on and the MG1 is rotating, we've measured as high as 260 or so volts fed back to this to charge it. But those two wires, the high voltage wires, go underneath the car. So once again, if you're lifting the car, look out that you don't put your lift hoist points on the cabling. Of course, it's in a protective housing that you can see there, and I've removed some of it just to hang it on the wall. But unless the system is turned on and these contactors are closed, which means you have to have your foot on the brake and hit the power button at the same time and have the ready light on the dash, unless all of that happens, there is no power on these cables. These are DC cables that go from the back of the car all the way up underneath the hood, and those two cables connect to the inverter converter assembly right here underneath the hood. There's no power on those if the key is off. But don't make an assumption. Make sure that before you disconnect or take any before you disconnect anything or replace anything, grab a multimeter, a high voltage class 3 1000 volt rated meter, and make sure that there's no voltage before you put a wrench on something or touch something. But you should be wearing your personal protective equipment. So that's our DC cabling that goes all the way from the battery to the inverter converter assembly underneath the hood. And then we have short 3-phase cabling that goes from the inverter converter assembly to our motors, the MG2 and the MG1. Those won't have any AC power on them unless the vehicle is moving, which you should never tow one of these because we've got a spinning magnet or set of magnets inside of a coil of wire which will create, through induction, power, and it's got to have somewhere to go, and you can damage the inverter converter assembly because it has nowhere to go. But those cables won't have any power on it unless the vehicle is moving or if the engine is running. MG1 right here can be spinning and acting as a generator, and probably will be spinning if the engine's running, to have an AC voltage that's converted to DC and sent back to our high voltage battery for charging. And then it's our high voltage battery through the DC to DC converter that steps it down and charges the auxiliary battery, the 12 volt battery in the back of the car. So on this system, if you needed to disable it quickly for whatever reason, just disconnect the negative battery cable if you can get to it. Make sure the power is off. Turn the power or hit the power button to shut the system off. As long as the power is off, there should be no power, or as long as the power button is off and the ready light is off, there should be no power on any of those orange cables. Nothing. Everything should have 0 volts on them. But if in an accident you need to disable the system, since the 12 volt battery is in the trunk area that you can't get to very easily, we rely on these contactors to go open to make the system be disabled. But if you can get the trunk area open, you can get to the battery to disconnect it, or you can get to that service plug grip and disconnect it, as I showed you, to disable the system. But you don't need to be really afraid to work on one of these. Don't panic. Don't think that just because you touch an orange cable that you're going to die. That's simply not the case. But don't make assumptions that there's no power there either, although probably in most cases, as I said, if the ready light is off, the engine is off, the keys are gone, and you're not towing the vehicle, there'd be no power there anyway. So this has been a demonstration of the hybrid system of a 2004 through 2009 Toyota Prius. This is the second generation system. The first generation system is very similar, and the third generation system is very similar. But the third generation system, I've got some photos over here. The third generation system, the power inverter module is a much smaller module. The second generation one is on the left, the third generation one's on the right. And then this is the electric motor MG1 and MG2 assemblies. The ones on the left are the second generation Prius. The ones on the right are the third generation Prius. And these photographs are off of Toyota's press website that are freely distributable. And then also the second generation on the left, third generation on the right. In the electric motor pack assembly in the Transaxle, the third generation Transaxle has an additional planetary gear set for reduction for the MG2 motor, which allows the motor to be smaller, spin faster, and have higher torque and higher output. And as you can see in this picture here, the second generation MG2 is huge, really wide, and the third generation is much narrower. We also got rid of the chain drive in the second generation and went right to a gear drive in the third generation. And this is the transaxle housing split apart where the motor assemblies have come out of. So this has been a demonstration of the operation of the high voltage hybrid systems of a Toyota Prius 2004 through 2009.